Today we're going through a brief introduction to Mechanic Station 5 fluid conductors. We're going to review the tools available at the station as well as review the available laminates and understand what information is available from those charts. Let's get started. To start, let's review the tools available at the station. The first tool you'll have available is the dial caliper. This will be used to measure the inside diameter of the hydraulic hose, remembering that hydraulic hoses are defined in size by their inside diameter and bend radius. Or the caliper can be used to measure the outside diameter and wall thickness of a particular tube, either steel tubing, copper tubing, or nylon tubing, all of which are defined by their respective outside diameters and wall thicknesses. The second tool available is a magnet. While the specific magnet available may vary, the purpose and usage is the same. For steel tubing, the magnet can be used to identify carbon steel versus stainless steel. The high-quality stainless steel used in hydraulic tubing is non-magnetic. Therefore, the magnet can be used to differentiate stainless steel from carbon steel. Now let's take a brief overview of the purpose of Station 5. The initial step to properly identify a given conductor is to perform a basic inspection to determine the type of conductor and then to recognize how that specific conductor is defined. The initial step is to measure the appropriate diameter based on the type of conductor. For example, the inside diameter would be measured for a hose and the outside diameter would be measured for tubing. Next, measure the wall thickness where appropriate for the various types of tubing, either steel, copper, or nylon. The next step is to use the appropriate charts for the given conductor being identified to determine the available pressures, either maximum working pressure or burst pressure depending upon the information available from the given chart. After reviewing the charts, it may be necessary to then calculate the corresponding working or burst pressure using a safety factor of 4, pending what information is available on the chart. In some instances, the charts may list both the working and the burst pressure already so that the calculation is not necessary. The tools available will include the dial caliper, a magnet, and the corresponding reference charts, which we will review in detail momentarily. As a reminder, when measuring metal tubing, ensure that the end used for measurement has been properly cleaned and deburred. Taking measurements on an end that was not properly deburred may result in incorrect and inaccurate measurements. Now we're going to review the laminate charts available within Station 5 of the mechanic certification. Shown is an excerpt from laminate 104 from Station 5. Let's assume you have a piece of steel tubing and that you're trying to identify, and since the tubing is defined by its outside diameter, you measure 1/2 inch. Reviewing the segment of the laminated chart, the measurement would place you somewhere within this region of the chart for pressure values. The next step would be to measure the wall thickness from an end that has been properly deburred. Let's again assume you measure 0.050 inches using the dial caliper. From the chart, you should be able to find the closest wall thickness measurement to that physically measured to be 0.049 inches, indicating the defined wall thickness based on the measurement and available within the chart. Be sure to use the values from the chart and not the actual measured dimensions. Next, you can use the magnet to determine if it is stainless steel tubing or carbon steel tubing. Let's assume that your measurement is magnetic, indicating that the conductor is carbon steel. This points you to the center set of columns within the chart, indicating that we're dealing with carbon steel. From the chart, we can then determine and select our appropriate burst pressure, in this case, 9,800 psi. Finally, from the chart, we can see that there are 6-to-1 and 4-to-1 safety factors used. Using the safety factor of 4-to-1, we can determine the rated maximum working pressure, and in this case would be 2,450 psi. If you were using a different safety factor, you could calculate the working pressure from the determined burst pressure by dividing by the desired safety factor. Now we will look at laminate 204 from the Mechanic Job Performance Station 5. This is the SAE J517 100R series hose maximum working pressure chart. Remember that hoses are defined by their inside diameter, so make sure that the inside of the hose would be measured. As an example, let's assume you measure a hose to be 1/2 inch inside diameter. This would place you here on the row within the chart. From an inspection of the hose sample, you can determine from the ley line that perhaps this hose is a SAE 100R2 construction, placing you here within the column on the chart. You can then connect the row and column to determine the maximum working pressure of the hose, which in this case is 3,988 psi or 27.5 megapascals. Next, you can calculate the burst pressure using a safety factor of 4:1, which is standard for hoses, multiplying the working pressure by 4, resulting in a burst pressure rating of 15,952 psi or 110 megapascals. There is another important note to share about the SAE J517 100R series hose chart shown. If you note at the bottom of the chart, there are two SAE hose constructions, 100R5 and 100R14, which are noted by the blue asterisks on the upper part of the chart. These hoses do not follow the standard sizing definition of dash size being equal to the fractional size multiplied by 16. These two hose constructions are sized differently. If you take a 3/8 hose, for example, normally a 3/8 inch hose would be a dash 6, but in this specific case, it is a dash 7. Just keep in mind, as you're using this chart, the 100R5 and 100R14 hoses are different. Another thing to note within the mechanic and the CNC study manuals is the reference to ISO 18752 standard. The industry is seeing a gradual shift towards more and more ISO construction hoses being used within the United States. Unlike the SAE 100R series hoses that have different pressure ratings based on the size of the hose, the ISO 18752 constructed hoses have the same pressure rating independent of the hose size for a given construction class. Note that the class is just the pressure rating in megapascals multiplied by 10. For example, a class 35 has a pressure rating of 3.5 megapascals, which if multiplied by 10 gives the class rating of 35. Next, we will review laminate 304, which is specific to copper tubing. Copper tubing, just like the other types of tubing, can be measured by its outside diameter and wall thickness. Copper tubing can be visually identified by the color. Just like the steel tubing chart that we looked at a few moments ago, the copper tubing chart identifies the burst pressure rating of the tubing. The copper chart includes a calculation used to determine the burst pressure rating based on the material strength. The chart works similar to the steel tubing chart. For example, if you measured the outside diameter of copper tubing sample to be 3/8 of an inch, that would place you within this section of the chart. Next, let's assume you measure the wall thickness to be 0.060 inches. The chart would give you 0.058 inches as the wall thickness size that corresponds to the actual measurement. This would be the identified wall thickness. Next, from the identified outside diameter and wall thickness, the burst pressure can be determined from the chart, which in this case would be 9,899 psi. Finally, if we wanted to determine the working pressure based on a 4:1 safety factor, which in this case is not listed on the chart, One could calculate the working pressure by dividing the burst pressure by the safety factor of 4. This would result in a working pressure of 2,474.75 psi. Now let's review laminate 404, which contains two different charts. We will look at the top chart first. The first chart is used to determine the group of the nylon tubing constructed based on the measurements of the outside diameter and wall thickness. The group identified will then be used on the second chart. For example, let's assume a nylon conductor is measured and found to have an outside diameter of 1/4 inch and an actual wall thickness measurement of 0.065 inches. From the chart, you will find 3 different 1/4 inch outside diameter tubes that have various wall thicknesses. Based on the chart, we can review what is available and see that the Group 2 1/4 inch outside diameter matches closest to the measured values, giving an outside diameter of 1/4 inch and a wall thickness of 0.062 inches, as well as Group 2 being identified. We will use the group identification on the next chart. Now that we've identified the group construction of the nylon tube, we can determine a burst pressure based on a target operation temperature. If we assume 140 degrees F, we can use the table to follow the temperature up to the corresponding group curve and then horizontally to identify a burst pressure rating. We can then calculate the working pressure for a 4-to-1 safety factor by dividing by 4 or multiplying by 1/4. So from the chart, we can identify that the burst pressure rating of 1,200 psi and a calculated maximum working pressure of 300 psi for a target temperature of 140 degrees Fahrenheit. I hope you found this video helpful in better understanding the process to identify various fluid conductors. Feel free to reach out to us if you have any specific questions. Next, measure the wall thickness where appropriate for the various types of tubing, either steel, copper, or nylon. The next step is to use the appropriate charts for the given conductor being identified to determine the available pressures, either maximum working pressure or burst pressure, depending upon the information available from the given chart. After reviewing the charts, it may be necessary to then calculate the corresponding working or burst pressure using a safety factor of 4, pending what information is available on the chart. In some instances, the charts may list both the working and the burst pressure already so that the calculation is not necessary. Reviewed, the tools available will include the dial caliper, a magnet, and the corresponding reference charts, which we will review in detail momentarily. As a reminder, when measuring metal tubing, ensure that the end used for measurement has been properly cleaned and deburred. Taking measurements on an end that was not properly deburred may result in incorrect and inaccurate measurements. Now we're going to review the laminate charts available within Station 5 of the mechanic certification. Shown is an excerpt from laminate 104 from Station 5. Let's assume you have a piece of steel tubing and that you're trying to identify, and since the tubing is defined by its outside diameter, you measure 1/2 inch. Reviewing the segment of the laminated chart, the measurement would place you somewhere within this region of the chart for pressure values. The next step would be to measure the wall thickness from an end that has been properly deburred. Let's again assume you measure 0.050 inches using the dial caliper.